If you are studying the syllabus of Pharmaceutical Organic Chemistry 3 of Savitribai Phule Pune University, then in that subject there is one unit known as name reactions. Here you have to study name reactions. Some 12, 13 name reactions are there, and most of the time it is confusing because you have to remember all that name reaction, their starting compound, their reaction condition, intermediate, and what it is forming. I mean applications. And sometimes overlapping happens and confusion happens. So what I tried here is try to cover all that part on on a single page. So on this single page, you are seeing all the reactions and actually the key essential ingredients of the reaction. So you can remember all the reaction. You can write it down. You can take a print of it, and it is for revision and as well as it is for comparative study of these rearrangements or reactions. So you see this. This is like pinacol, pinacolon rearrangement. This is the reaction name. And in this reaction, reactant are pinacol. Pinacol means 1,2-diol is there, and we have to use acid as a catalyst. Reaction condition is obviously acidic it is, and intermediate form in this reaction is carbocation. There are two carbocations formed. First is formed, then second carbocation is formed. There is migration, one to migration, one to shift. So this is part of this intermediate of this pinacol rearrangement, and it is used to prepare ketones from 1,2-diol. So you can understand that with this single line you can able to recall this pinacol rearrangement. Same is the case with other reactions, say Hofmann reaction, or it is also known as Hofmann degradation reaction. In this reaction, amide is used, halogens are used, and alkali is used, especially sodium hydroxide is used. Reaction condition is alkaline, and the intermediate form is isocyanate, which is characteristic. And in this reaction, amide is converted into primary amine. But one important thing is there that compound is having one carbon unit less. Baeyer-Williger oxidation. Here we have to take ketones and we have to use peroxy acids. And in this reaction, acidic condition is maintained, and it is a concerted mechanism. The bond breaking, bond formation happening simultaneously. And here, as name indicate, oxidation takes place. If ketone is there, oxidation of ketone will produce ester. And if the ketone is cyclic, then the cyclic ester, which is known as lactones. Reaction benzylic acid, here as name indicate, we have to take benzyl, and alkaline condition is maintained. Here also, like pinacolone, there is 1,2 shift, migration of group from first carbon to second carbon takes place. And in this reaction, the product form is alpha hydroxy carboxylic acid. The reaction Beckmann's rearrangement, the characteristic ketoxime is the reactant. Acidic condition is maintained. Carbocation is formed in this reaction, and there is 1,2 migration, 1,2 shift, and finally we are getting amides. Schmidt rearrangement, here we have to take carbonyl compounds, or we can also take tertiary alcohols or alkenes, and we have to take characteristic hydrozoic acid. Acidic condition is required to be maintained, and the intermediate form is isocyanate if we are taking carboxylic acids, and acidohydrin if we are taking ketones. And in this reaction, there is a formation of amines, nitriles, amides, or imines. The reaction Claisen-Schmidt condensation, here aromatic aldehyde, without alpha hydrogen we have to take, and aldehyde or ketone we have to take, which is having alpha hydrogen. Basic condition we have to maintain, and beta hydroxy carbonyl compound is the intermediate, which then produces alpha beta unsaturated carbonyl compound. Clemmensen reduction is a characteristic reaction used for reducing carbonyl compound, ketone especially. In this, we have to use zinc amalgam. Acidic condition is required to be maintained. And actually, this reaction is considered to take, two-way. I mean, two pathways are proposed. One is carbon anionic mechanism, second carbenoid mechanism. And the product form is alkanes. The reaction Wolff rearrangement. Here the reactant is alpha diazoketone, and in this reaction we have to heat or we have to use light, which is known as photolysis. The ketene is the intermediate, and the product is carboxylic acid or cyclic compound, which is four membered. The reaction Oppenauer oxidation, as name indicate, is oxidation reaction. Here we have to take alcohol. This alcohol will oxidize into ketone, and in this we have to use characteristic catalyst aluminum alkoxide, especially aluminum isopropoxide, and we have to take one ketone. Condition is depending upon the alcohol and alkoxide used, reaction condition, and the characteristic cyclic transition state is the intermediate. Here, conversion of primary alcohol to aldehyde or secondary alcohol to ketones takes place. Next is Deakin reaction. In Deakin reaction, aromatic aldehyde or ketone is used, hydrogen peroxide is used, alkaline condition is required to be maintained, aryl formate or alkanoate is the intermediate, and the product form is characteristic catechol. The last reaction, Bus reduction, as name indicate, it is a reducing reaction, and a reduction takes place in this reaction. Aromatic compound we have to take, alkali we have to take, alkali metal we have to take, and liquid ammonia and alcohol we have to take to carry out this reaction. Cyclic diene, characteristic cyclic diene or alkene is formed. Here, the reduction of aromatic compound to cyclic diene, that is 1,4, especially 1,4 cyclohexadiene is formed. So this is the one-page summary of all that reactions. And with this, you can read all this reaction. You can find the differences. You will find the similarities, and you will retain the information.